I'm going to go ahead and do an example problem for to sample Z interval for difference in proportions. Just for the presidential election in November 2009, a local newspaper conducted a poll of residents in a medium-sized city and found 120 of a simple random sample of 250 men intended to vote for Barack Obama and 132 out of a simple random sample of 240 women intended to vote for Obama. Construct and interpret a confidence interval for the difference in proportion of men and women who supported Obama in this city. So I'm going to go straight into state. So state, I need to define both of my parameters first. So here I'm going to choose to do letters instead. So I'm going to do, this one says men. So this would be proportion of men in this medium-sized city who intended to vote for Obama in 2008. Portion of men in this, so intended to vote for Obama. So success is intended to vote for Obama in 2008. Our population is men in this medium-sized city. So then let PW be proportion of women in the city, in this medium-sized city who intended to vote for Obama in 2008. And then we go into our plan. I should put these side by side, not plan. So we want to estimate the true difference in proportions So I specify my direction here. I don't really have a motivation to go one way or the other at this point, so I just have to specify to keep it the same. Since I wrote M first and W second, I'm just going to go ahead and do that way. There's nothing in this problem that would make me want to say one way or the other. So I want to estimate the true difference in proportions, PM minus PW. Where it says here of context populations, portions of men who intend minus proportion of women, true difference in proportion of men. Let's say versus, because we've already said proportion and subtracting here. But I haven't talked about population yet. They both happen to be from the same population, or both from the same area. So sometimes I can't like put this together from the medium-sized city at the end because they might be completely separate. So this I'll erase this, but this portion like through here is going to vary a little bit problem just based off of like what makes sense or what sounds better. So proportion in medium-sized city with 95% confidence. So plan, we have to start with method. This is a 2-sample Z, not T, because it's proportions. We're currently doing a confidence interval, not a test. And we're doing 2 of them, so it's for difference in proportions. Random. Again, it's going to alter a little bit. Both of them specifically said SRS. Remember, you cannot say SRS unless it literally is an SRS. This one also specifies SRS. So we can say states that both men and women were simple random sample from this medium-sized city. And both of them happen to be random selection. Usually it's, I don't know that I've ever seen a case where one of them's random selection, one of them's random assignment. So usually they're both the same. So here I have to check it for both. I'm gonna do it for men first because I started out with men first. Now I do P hat men, remember, because I don't have PM. Then I'm doing NM times 1 minus P hat M. And W, P hat W. And NW 1 minus P hat W. So going back to these, when we're dealing with P hat there, this is actually the number of successes in this sample, number of failures in this sample. So we can go with the numbers that it gave us here. Here, 120 of them were male that do intend to vote. So out of 250, that leaves 130. For women, it was out of 240 and it was 132. Out of 240, so 108. And each of these were greater than or equal to 10. Residents of this medium-sized city men that intended to vote I'm shorthanded even more. And I'm going to show you a different way that I do this too on Monday. And then vote for Obama. Like I said, I'm going to show you a different way to do this, but I want to start out this way. And then so we can use normal approximation. And then I wrote too big, so I'm going to go to the next slide. Conditions end up being the majority of 2-sample problems. Oops. So we have to do this for both. There were a lot of you are just putting greater than. You need greater than or equal there. There are 250 males, which means there need to be at least 2,500. There were 240 women. Which means there need to be at least 2,400. In this medium-sized city. And again, sometimes based off of wording, you can write it like this, where the end of it's the same, and sometimes you can't. Just all depends on context. So do. So we've got that P hat M is 120 out of 250. Which gives us 0.48. We've got P hat W is 132 out of 240. Which is 0.55. Our N for men was 250. Our N for women was 240. Our confidence level that we were given was 95%, which means that is a Z of 1.96. So I specified my direction as men minus women. So I've got to keep that the same. Plus or minus my critical value times standard deviation. Remember, standard deviation, I have to do one big square root. I do everything for the first one first. So P hat M, 1 minus P hat M over NM. Oh, I did not write this symbol right here on the generic. I just realized that. I'll make sure you'll do that Monday, but I would go ahead and do that now while you're watching these notes. That this should be N1, that should be N2. I don't think I wrote that. And then so here, I think it's easier using the decimals now. So 0.48 minus 0.55 plus or minus 1.96 square root of 0.48 times 0.52 divided by 250 plus 0.55 times 0.45 divided by 240. What are we estimating in between? That parameter PM minus parameter PW is between the two numbers. So this should be what goes in between now. This is one where I would definitely use stat test in your calculator. So stat test, we're on a 2 proportion Z test. My X1 is 120. My N1 is 250. My X2 is 132. My N2 is 240. I did 2 tests, not 2. Stat 2 prop Z int is B. So 120, 250, 132, 240, C level 0.95. Calculate, and this gives you negative 0.1583 and 0.0183. So if I'm subtracting men, proportion of men minus proportion of women, and I get a negative number, that means our proportion of the second thing is higher, because smaller number minus bigger number gives you negative up until here. So this is saying that the proportion of women is lower by almost 2%. This is saying the proportion of women is higher by almost 16%. So it falls somewhere in between there. So we are 95% confident that the true proportion PM minus PW, I'll write the same way I did before, of men who intended to vote for Obama in 2008 versus women who intended to vote for Obama in 2008 from this regular or from this medium-sized city falls between negative 15.83% and it doesn't matter if you write it as percents or not. You can write it that way or as the decimals themselves. So then your homework is to complete the other practice problem that is on the practice problems for today.